Hi everyone, let's go over some of the questions from practice test 3 in preparation for your exam. First, let's take a look at this question. What is the difference between a relative extremum and an absolute extremum? When you say relative extremum, it will be the extremum, either a maximum or a minimum within an interval. So in other words, if you have a function, you would look at some open interval and then you see with respect to the points in that interval if that point is the maximum or the minimum. So that is one of your relative extremum. So that means that you could have several relative extremum. You could have 1 or 2 or 3 minimums or 1 or 2 or 3 maximums, depending on the behavior of your function. Whereas when you say absolute extremum, that is the greatest maximum, for instance, or the least minimum among all the relative extremum. So if you are going to compare you include the endpoint. So if you have a closed interval, or if you have an interval, you are going to look at the endpoints as well and compare that to the values. The highest value is the absolute maximum, and the lowest value is the absolute minimum. So to answer this question, a relative extremum is any peak or valley, including endpoints of a function, while an absolute extremum is the greatest or the least value of a function. A function can have as many relative extrema as possible. However, a function can only have at most one absolute maximum and at most one absolute minimum. Now let's move on to this question here. Find the location of the maximum absolute extremum for the function. So take note, you are looking for the maximum absolute extremum. That means the highest point. So in this case here, you're just going to look at that highest point. This is the highest point of the function. So that means the location of this point is at x equals 1. So at x equals 1, this is the absolute maximum value of the function. The answer is letter C. Now for this question, you are asked to find the location of the minimum absolute extremum. That means the least value of the function, the minimum absolute. Absolute means the least of all, in this case, because that's the minimum, so it's the smallest value of the function. So if you look at the function here, the lowest value, smallest value will be this point here. That point is the absolute minimum of the function, and it is located at x equals -2. So when you're asked for the location, you give the x coordinate of the point. So the answer is x equals -2. Now let's consider the following question. Find the minimum absolute extremum as well as all values of x for where it occurs on specified domain. So in this case, we're given this closed interval here, -2 to 5, and the function is given by this polynomial expression. Take note, we are asked to find the minimum absolute extremum, so that would be the lowest value. And how do we proceed to do that? First, let's look at the critical numbers. So that means we're going to find the derivative of the function. So the derivative of f of x will be, 1/3 times 3x squared minus 2 times 2x plus 3. And then you simplify that. This cancels. So this is x squared minus 4x plus 3. This is the derivative of the given function here. Make sure to check before you proceed. Now, you equate this to 0. That's the critical numbers, because the critical numbers, those where you could possibly find relative extreme values. That's where the possible location for the local or relative max or relative min. So you equate this to 0, solve for x. That's how you get the critical numbers. You can do this by factoring this equation. So the factors are x minus 3 and x minus 1 equal to 0. So that is x equals 3 and x equals 1. Then what do you do to proceed? You are going to plug in all these values to the function, and you're going to compare the results. Now, because the domain given, the values of x, that's the domain given, is a closed interval. That means we're also going to evaluate the function at the endpoints of the interval. We include the endpoints of the interval because if it is a closed interval, then the endpoints could also be a possible location for a maximum or a minimum value. So you have f of 3. That means you evaluate this original function at x equals 3. And then you plug this into your calculator. Okay, so I'll plug this in. I'll write this down first, then I'll plug it in later. So that's if this is 1, if this is 1, that's 1. This one will just be 1 cubed is just 1. So that will just be 1/3 minus 2, because 1 squared is 1, and then plus 3 minus 4. Then you simplify this, you will have, that's negative 6 plus 3 is negative 3. So that is negative 2 and 2/3. And then you also include f at negative 2. So this one, if it's complicated, then you can then plug into your calculator. So this is the function evaluated at negative 2. We'll plug that into our calculator later, and also evaluate the function at x equals 5. So all you need to do is replace x by 5, by the value of x. So you use that function. And then let's go ahead and plug this into our calculator. All right, so I went ahead and plugged into this calculator, and I realized that this is a mistake. This should be a 3. So first we will evaluate the function when x is equal to 3. Right, so this expression here will then be plugged into the calculator. I used the Desmos Scientific Calculator. So when x is 3, the value is negative 4. Now, when x is equal to 1, that's the other critical number, the value is negative 2.67. And then when x is equal to negative 2, this is the value, negative 20.67. And when x is equal to 5 is equal to 2.67. Now, comparing all these values here, the highest is 2.67 and the lowest is negative 20.67. Now if we go back to the problem, we are asked to find the minimum absolute extremum. The minimum absolute extremum is the least value, and the least value is equal to, so the lowest value is this one, this value here. But as you notice in the question, this should be in fraction form. So to do that, you're just going to convert this to fraction. So that is equal to negative 62 over 3. Negative 62 over 3. That's the value. And that is located at x equals negative 2. So that's letter B is the answer. For the next question, we are asked to find the absolute extremum. So if you're asked to find the absolute extrema, that pertains to the absolute maximum and the absolute minimum. So we're looking for the absolute extrema if they exist. So if it has an absolute maximum, we'll write it here, and then we will indicate where this is located. We'll indicate the value for x where the local where the absolute maximum value occurs. And the same thing also for the absolute minimum value. So to do that, we will first find the derivative of the function and then find the critical numbers. Those are the possible location for the absolute maximum and absolute minimum. And also, we'll look at the endpoints of the function. So the absolute max, absolute mean could also possibly be at the endpoints. Okay, so let's go ahead and find the derivative. We are given a rational function here, so that the derivative just follow the quotient rule. So it's low the high, so low, copy the denominator, 5 plus x. The high, differentiate the numerator, that's -1, minus high, copy the numerator, 3 minus x. The low, derivative of the denominator, which is 1, all over low squared. And then you square that. Then you simplify. So this is equal to 5 plus -5, so that's -1, distribute that to each term in the parentheses. That's -5 minus x. Now the one here, that will remain to be 3 minus x, and we have a negative sign here, so when you remove that parenthesis, you will have -3 plus x. And then the denominator will be 5 plus x, and then square. Now, this negative x cancels with that. So you have -5 minus 3 is -8. So you have -8 over 5 plus x quantity squared. Now, it should be on this domain here. So if you look at that critical number, if you look at this critical number here, f of x, the critical number will be the expression for which this becomes undefined. So when will this be undefined? That is when x is equal to -5. Is there any value of x for which this is 0? That means you equate the numerator to 0. Since the numerator does not contain any variable, then that means that there is no x for which this becomes 0. Because that will only be 0 if the numerator is 0. So since it does not have any variable, that means it is always equal to -8. The numerator is always equal to -8. So in other words, we only have this as our critical number. Now, this is, if you look at this one, this is located outside of this interval here. So that means we're not going to include this. So we're not going to include this as a possible location of our absolute extrema, because we're only considering the absolute extrema on this closed interval here, and this is outside that closed interval. So we'll just go ahead and plug in the endpoints here, 0 to the function. So 3 minus 0 over 5 plus 0. So that is 3/5. And the other one is at 5. So that is 3 minus 5 over 5 plus 5. And that's -2 over 10. And that is equal to -1/5. So this is your maximum. That's your absolute maximum, and this is your absolute minimum. So your absolute minimum is this value, and it is located at x equals 5. The absolute maximum is 3/5, and it is located at x equals 0. Now let's move on to this next question. Suppose P of x, which is given by this expression, and x is greater than or equal to 3, is an approximation to the total profit in thousands of dollars from the sale of x 100,000 tires. Find the number of thousands of tires that must be sold to maximize the profit. So in this problem here, we are going to maximize the profit. So we are going to maximize the profit function. So the total profit function is given by this. In other words, we want to know the value for x for which P of x is a maximum. So to proceed, we will first have to find the derivative of this function here. So let's get P prime of x, and that is equal to negative 3x squared plus 24x minus 36. So we took the derivative of the function. Then now we equate this to 0 to find the critical number. So to find the critical number, you look at the coefficients first and notice that they're all divisible by 3. So you can reduce this to, let's divide everything by negative 3. Let's divide both sides of the equation by negative 3. So we have positive x squared. 24 divided by negative 3 is minus 8, so negative 8x. And negative 36 divided by negative 3 is positive 12, equal to 0. And now let's factor this out. So we have x minus 6 times x minus 2 is equal to 0. So x is equal to 6, or x is equal to 2. These two are the possible location for the maximum. Okay, so now we want to know when will this be, where is the function a maximum? Now, to do that, we can use the second derivative test. So let's use the second derivative test to determine which of these two values of x will give us a maximum profit. So let's get the second derivative of the function. So the second derivative of the function will be, so refer to the derivative here, not to the simplified expression, but to the original one. So we have negative 6x. The derivative of negative 3x squared is negative 6x. And the derivative of 24x is plus 24. Then using the second derivative test, we will plug in these values of x here to the second derivative. So we will evaluate it at first x equals 6. So you have negative 6 times 6 plus 24. So that is negative 36 plus 24. That gives you negative 12. Now, we know through the second derivative test that if the second derivative is negative, the function is concave downward at that point. So if it is concave downward at that point, then this point here is a maximum, because this could be a possible location that could be a maximum or a minimum. Now, then we could look at the value of the second derivative at x equals 2. At x equals 2, we have negative 6 times 2 plus 24. So negative 6 is negative 12 plus 24 is positive 12. Then we know that at that point it is a minimum. So minimum at this point. Now we're particularly interested at the value of x for which the profit is a maximum. The profit is a maximum. So that means that the value of x for which it is maximum is at x equals 6. So that means 600,000, because x is in 100,000. So the answer is 600,000. Now let's proceed to this next question. Find the minimum value of the average cost for the given function on these given intervals. Now, we are asked to find the minimum value of the average cost, but we are only given the cost function. So the first step is to find the expression for the average cost. So the expression for the average cost of the function, average cost, is just equal to the cost function, c of x, divided by x. So let's say, for instance, we call our average cost as a of x, and that is equal to c of x over x. So your c of x is this function here, x cubed plus 38x plus 128 divided by x. And then to proceed, let us find the derivative of a of x. So to differentiate this, instead of using the quotient rule, let's just go ahead and simplify a of x by dividing each term by x. So you have x squared, that is x cubed divided by x, and then 38x over x is equal to 38. Then 128 divided by x is just 128 over x. Then next is to differentiate that. But before we differentiate this, let's just write this in exponential form. So you copy x squared plus 38. Now 128 over x will be written as 128x to the negative 1. Then differentiate a. So a prime of x is equal to derivative of x squared, which is 2x. The derivative of 38 is 0. And then the derivative of 128x to the negative 1 is just negative 128x to the negative 2. Then now you can simplify this, or you can write this as 2x minus 128 over x squared, which is also the same as 2x cubed minus 128 all over x squared. Then you find the critical numbers. So to find the critical numbers, you're going to get the zeros of both numerator and denominator. So that means you equate the numerator, 2x cubed minus 128 to 0. And then you solve for x. So you have 2x cubed. You add both sides by 128, so that makes it 2x cubed equal to 128. Divide this by 2, and that gives you 64. So x cubed is equal to 64. Therefore, x is equal to 4. You take the cube root of both sides. Then you do the same thing for that denominator. X squared is equal to 0, so therefore x is 0. But if you go back to the given interval here, it says that the interval is from between 1 to 10. So starting at 1 to 10. So 0 is not part of that closed interval. So that means we're not going to include the 0 here. But instead, we're just going to use this value of x here. X equals 4. So to find the minimum value, so we now have this critical number, that's our critical number. The next step is to evaluate the function. So let me just erase that. We will evaluate our function at the endpoints of the interval and at the critical number. So for this, we will evaluate a at 1 and then evaluate a at 1. So we'll use the simplified expression here for a. So the average cost at x equals 1 will be 1 squared plus 38 plus 128 over 1. So, and then you plug that into your calculator. And then you have a at 4, and then that will be equal to 4 squared plus 38 plus 128 over 4. And then a at this endpoint here, 10, which is equal to 10 squared, so x squared, 10 squared plus 38 plus 128 over 10. And then for this last interval here, that critical number is actually for both because we have the same function. So in this case, for letter B, we just need to evaluate the function at the endpoints of the interval because there's no critical number that is within this interval here. So we're also going to evaluate our function at x equals 20. So we have 20 squared plus 38 plus 128 over 20. Then let's plug this into our calculator. So by plugging this into the calculator, these are the values that I got. So when x is equal to 1, the average value is 168. When x is equal to 4, it's 118. And when x is equal to 10, it's 150.8. So between the interval 1 to 10, the least value is 118. So that is when x is equal to 4. So I will have 118 here as the minimum value for the average cost. Now for letter B, the interval, it is over the interval 10 and 20. So as I've said, between 10 and 20, there's no critical number there because from our calculation, the critical number is 4. And that is already outside of the interval here. So we're just going to evaluate the function at the endpoints of that interval. So at x equals 10 and at x equals 20. At x equals 10, this is the value I got upon plugging into the calculator, this expression here. So I have 150.8, and then for x equals 20, I got 144.4. So I'll just have to pick the least value, the smallest value, which is 150.8. So between those two, the smallest value is 150.8, and that is the minimum value of the average cost over this interval here.